Alright, I checked number 27. It was correct. Alright, on number 28, we are using de Moivre's theorem to solve this. De Moivre taught us how to take complex numbers and raise them to powers. His theorem only works though when you have it written in trig form. So we have to do that again. So we graph it, the reals minus 7 and the imaginaries plus 7. So there's the point. And we can get the hypotenuse by c squared equals 7 squared plus 7 squared. So it's 49 plus 49, second function, 9.90. Alright, so remember in trig form, that number goes out in front, then cosine of an angle plus I sine of an angle. And we can see, I think you can see this cuts straight through there. It's a 135 degree angle. So 9.90, this is 135 degrees. Alright, so this is what we have to raise to the fourth. And de Moivre noticed that you just multiply this times that. 9.90 times 4 equals 39.6. And this cosine, then he noticed that this angle is multiplied. Oh, I did that wrong. This number is raised to the 4 by de Moivre. So the number out here, 9.90, is not multiplied by 4. It's raised to the 4. 9.90 raised to the 4th. It's much bigger. 9605.96. And this number is multiplied by 4. So we have cosine 135 times 4 is 540. And this will be the same. 540 is bigger than 360, so we'll reduce it back by subtracting 360. It equals 180. So this is 180 as well. So to go back to standard form from this, we see that 180 degrees puts us right there. And at that point, we go this magnitude from the origin is 9605.96. But you can see, to put that in I and R, in the real part and the imaginary part, there's no imaginary part because we don't go up or down, we just go to the left. So it's negative 9605.96 in the reals and nothing in the imaginaries, so we don't usually write it. So that number is the correct answer. I think I might have rounded a little differently, but the key came very close, and let me see if I got it right. I did. All right. All right. Let's look at number 29. We have to write the first 5 terms, negative 7n minus 4. And we usually start with 1 unless we're told otherwise. So minus 7 times 1 minus 4 gives me minus 11 for the first term. And the second term, I put in n equals 2. Negative 14 minus 4. Negative 18. I put in a minus 3. I'm sorry, I put in a positive 3. And I get a minus 21 minus 4. Fourth term minus 28 minus 4, and the fifth minus 35 minus 4. All right. That is the first 5 terms of that one. Checking to see if I got it right, and I did. All right, on number 30, we're going to 33, so the end is in sight. We're supposed to look at this and come up with the nth term. So we need a rule or a generator with n in it, so that when I put in a 1, it generates a 4. And when I put in a 2 to my generator, it generates a 7. You'll notice I picked one that was quite doable because the difference between these are constant. So 4 to 7 is 3, 7 to 10 is 3. So I taught you back then, whenever that happens, 3n has something to do with it. So 3n is going to be in our generator, but let's see how close it gets us. So when I put a 1 in for n, I get a 3, but I wanted a 4. And when I put a 2 in for n, I wanted a 7, but it gives me a 6. So do you see that we're 1 off each time? So what if I just add 1? We'll check it for 3. 3 times 3 plus 1 is 10. 4. 3 times 4 plus 1. Yep. Okay. We got it. So some of them aren't quite that easy. You just have to try different things. Look for squares. Look for square roots. And see what you can come up with. If the signs are alternating, you'll recall we have to use -1 to the n or -1 to the n plus 1. So keep that in mind. All right, on number 31, we have the first term, and that's going to be 20. And then it recursively tells me that a sub k plus 1 equals a sub k plus 8. So we're going to generate 5 terms. They already told us a sub 1, the first term, is 20. So let's let k equal 1. So then we get a sub 1 plus 1, or a sub 2, which is this term, equals a sub 1, which is this term, plus 8. So 20 plus 8. Now let k equal 2. A sub 2 plus 1, or a sub 3, that's this term, equals a sub k, which is a sub 2, that term, plus 8. So maybe you see we're just going to be adding 8 each time. So we're going to get 44, and add another 8, 52. All right. This is the kind of question I will ask. Your little worksheet here asks you to actually come up with the generator. So I'm not going to ask you to do that, but I'm going to ask you to do this. All right, on 32, you're supposed to find the partial sum. So this is a summation sign, and this is the counter. And first we're going to put, it tells me I'm going to start my counter at 1, and then 2, 3, 4, on to infinity. But we're not going to sum that many up. We're going to find the third partial sum. It asks us to do that. So I'm only going to do 3 sums. Alright, the first one, when I equals 1, is 5 times 1/4, 5/4. The second one is when this goes to a 2, so we have 1/4 squared, which is 1/16 times 5. And then to the third, 4 times 4 is 16, times 4 is 64, 1/64 times 5. And so then we add all that up. So we can change them all to 64ths. Get 105/64. Let's see what was the answer. It is correct. All right, if you gave me that in a decimal, I would take it as well. It's 1.64. All right, lastly, let's see what we can do with this next sum. This time, they want the sum of the whole thing, no partial sum. So we're starting with 1 and we're going to infinity. And first of all, we'll generate a couple of these to see what they look like. So when I is 1, we get 4 times -1/4, and that is -4/4 or -1. The second, when I is 2, we get 1/4 times 1/4, which is 1/16, and 4/16 is 1/4. Let me write that out. 1/4 times 1/4 is 1/16 times 4 is 4/16, which is not 1/16, it's 1/4. All right. We'll do the next one. So when I goes to 3, we have -1/4 times -1/4 times -1/4, which equals -1/64 times 4. And we get -4/1/64. I'm sorry, over 64, which is -1/16. So, all right, so this is going to go on for an infinite number of steps, and our job is to figure out the sum in infinity. We can only do that if r, the common ratio, is between -1 and 1. So what am I multiplying this by to get this, and this by to get this? Well, you can see that I'm multiplying by -1/4. So, is that between -1 and 1? It is. If it is, then we can use this formula. A sub 1 over 1 minus r. A sub 1 is -1, and 1 minus a -1/4 will give us a -1 over 1 plus 1/4, or 5/4. Flip and multiply, and we can get -4/5. Let me see if that is correct. It is. All right. All right. We've come in several directions and studied various topics from our year. So let's call it quits. One more review session to go. Please take time to study these things, and you can start thinking about or actually making your card of those formulas, like this one, that you'll need for the test. All right. I just want you to do well and study as we go. Use your time wisely and carry on.